Hello everyone, welcome to my YouTube channel. Today I am excited to present a project that I have been working on this in the field of data warehousing. This project is all about collecting, cleaning and visualizing data from the world of cricket matches spanning from 2003 to 2023. In this project, I'll walk through the journey of this data warehousing project from the initial data collection to the final data visualizations. We will explore how I handled missing values and duplicates in the dataset to ensure data quality and data integrity. Here, starting with the libraries. Here I imported different libraries such as NumPy, Pandas, Matplotlib, and sklearn.preprocessing and sklearn.model selection. Now I will explain what are these libraries. And the NumPy and Pandas are commonly used libraries for numerical and data analysis in Python. And coming to Matplotlib is a popular library for creating data visualizations. And standard scalar is an object from sklearn.preprocessing used for standardizing data. And train test split is a function from sklearn.model selection is used for splitting a data set into training and testing sets. And Seaborn is a data visualization library built on top of Matplotlib that provides a high-level interface for creating informative and attractive static graphs. And here we are reading the data. Here this line of code reads a CSV file named records.csv located at a specific file in the path and loads it in a pandas data frame. Here it will read out. Here we are print data. Here it will read out in the whole data that dataset contains. So here it providing that the whole dataset contains 258,607 rows and 35 columns. Here in the next line we are running the data.info. This will give the output of whole information what the dataset contains. This is the output of that. Here the dataset contains match ID, date, venue, bat first, bat second, innings, over, ball, batter, striker. Like this, it contains 34 rows, 34 columns of 34 columns. Here missing val is equal to data dot is na dot sum is this part of code. This part of code is the used to find and count the number of missing values in each column of the data frame. Here missing val equal to data dot is na dot sum returns a data frame of the same shape as data with true, where the data is missing, and false otherwise. And sum is then used to calculate the sum of the true values along each column. And true is considered as 1 and also false is considered as 0. This effectively counts the number of missing values in each column. I want to explain this part of code with an example. Here, for example, if the missing value of venue is equals to 10, it means that there are 10 missing values is 10 missing values in the venue column. This information is valuable for data cleaning and data pre-processing as it allows you to identify and handle the missing data appropriately. And coming to this part, data and unique is it will print out the unique IDs and the whole unique columns of data which contains in the data set. And next, data.describe. Data.describe, it will describe the whole data. Means here we can see that here we get count, mean, minimum, and match ID. See, these are the values. It will describe the whole data. Coming to this part of code, I will explain this part of code wholly. Here, we are importing a libraries pandas, numpy, and cborn matplot. Here, seed equal to 42, which means that seeds to ensure reproducibility of random processes. Setting a seed with np.random seed to 42 will make sure that any 40 random number generation is consistent across the runs of the code. And we also sent Coming to this part of code, here we see that seed value equal to 42, which means that this code sets a random seed to ensure of random processes. Setting a seed with np.random.seed to 42 will make sure that any random number generation is consistent across runs of the code. Next we are setting pandas to display options. These lines adjust the display options for pandas. They set the maximum number of rows and columns to display to 1000. This is useful when you have large data frames to prevent truncation of the output. Next, reading data from CSV. Here, this line reads the data from CSV file name records1.csv located at the specified file path and loads it into a pandas data frame into IT20 data. Next, we are filtering the data. This line here innings 2 equals to innings 2 dot drop innings of innings 2. Here this whole part of code will filters the data frame ITT20 data to only include rows where the innings column has a value of 2. This effectively selects data from the second innings of a match. And coming to this line of code, this line of code will filters the data frame ITT20 data to only include rows where the innings column has a value of 2. This effectively selects data for the second innings of a match. And this part of code will ex- execute the removing rows with the balls remaining. This line removes rows from the innings 2 and data frame where the balls remaining column is equal to 0. It uses the drop method and the index attribute to drop these rows. And next it will print the number of matches and innings with the match ID. And it also print the total data frame length of the dataset and also length of innings 2 with the index. Here, at last I use innings2.head, which means that it will print the top 5 of the data in the dataset. And here is the output. Coming to this part of code, from sklearn.model selection, import train test split, and also from sklearn.preprocessing, import standard scalar. In the In machine learning, a dataset is typically divided into two main subsets, and the training data subset and the testing data subset. And these subsets serve different purpose in building and evaluating a machine learning model. Here we are in in this whole part of code. First, we are doing the training and testing of the data. Now, before explain this part of the code, I will explain about what is the training dataset and testing dataset. Coming to the training dataset, a training dataset is a portion of the data that is used to train or build a machine learning model. It contains a set of input and their corresponding target labels that the model is trying to predict. And the model learns patterns, relationships, and associations within the training dataset. And this model also adjusts internal parameters based on the data in the training set to make accurate predictions. And coming to the testing dataset, the testing dataset is a separate portion of the data used to evaluate the performance and generalization of the trained machine learning model. It also contains input features and their corresponding target labels. But the model has not seen this data during the training. The testing dataset is used to assess how well the data model can be predictions on new and unseen data. And the main primary reason for dividing a dataset into the training and testing subsets is to prevent a model from simply memorizing the training data, overfitting, and to assess how well the model performs on new unseen data. Now, I will explain about this portion of the code. Here, futures. This line defines a list of futures, names that will be used for modeling. These futures are the input variables that the model will use it to make predictions. And here we set up a cutoff date. This line sets a date as cutoff point for the splitting data into the training and testing sets. Data with a data before 2021 will be used for training, while data on or after this date will be used for testing. Next, we are splitting the data. We are uh, splitting the data for two types as train data and test data. Data less than the cutoff date will be remain as train data, and data greater than or equal to cutoff date will remain as the test data. Next, we are defining choices and target variables for training and testing the data. In these lines, the selected features and the target variables changed successfully into training and testing the data sets. Next, we are standardizing the features. This code creates a standardized scalar object and use it to standardize the future values. Standardized scales the futures to have a mean of 0 and a standard deviation of 1, which can be important for certain machine learning algorithms. And next we are printing the training and both the training and the testing data sets. And this is the output of the code. Next I'm going to explain about the accuracy. What is meant by accuracy? Data accuracy. Data accuracy in a data warehouse refers to the data in the warehouse reflects the real world entities and events. This is meant to represent. Accurate data is free from errors, inconsistencies, and discrepancies. Accurate data ensures the information used for both make decision making and reporting is trustworthy. Data accuracy in data warehouse refers to the correctness and the reliability of the data stored within the warehouse, and it is a critical step and aspect of data quality and is essential for making informed decisions. Now, I'm going to explain about this part of code for, for accuracy measuring. Here, we imported libraries for logistic regression and train set split and also random forest classifier and also for accuracy score. In this part of code, we are only going to discuss about the accuracy score. And in this, here we are defining data and phases. df is equal to innings2. It assigns the data frame innings2 to the df. And here we have phases like power play, middle overs, and final overs. And we are iterating through these phases. For I comma phases in enumerate phases, here this whole part of the code explains. This code loops through each phase and performs the following steps for each phase, and also it prints the pace of play. And we are defining a condition based on the phase to filter the data. Here again we are splitting the data based on the cutoff date. And next we are extracting the futures and target variables like training data and testing data for two variables x and y. Here we are standardizing the futures, and after that we are creating and training a logistic regression model. Here we are creating and training a logistic regression model with logistic regression of c is equals to 1. And here we are evaluating model accuracy, and the code calculates the accuracy of the logistic regression model on the testing data using model.score. And coming to the output, here the output of the code is a series of lines. It contains phase of play, accuracy of power play classifier, and phase of play in middle hours. And the accuracy is 0.73456, and the phase of play in final hours is accuracy, and the accuracy of final hours classifiers is 0.915217391. Before explaining this part of the whole code, I would like to explain about the logistic regression, random forest, and gradient boosting. And logistic regression will use is a machine learning algorithm. It is used is a and it also a statistical model used for binary classification problems in machine learning. And it is a supervised learning algorithm that predicts the probability of an instance belong to one of two classes, either yes or no, or 1 or 0, either spam or harm. And the overview of logistical regression is its objective is to use it when the dependent variable target is logistic regression in data warehousing also. In data warehousing, logistic regression may be used as part of data analytics and reporting process. It is not a data warehousing technology itself, but rather a statistical tool that can be applied to data stored in data warehouse. Here how it can be used in data warehousing context. It is used for analysis, predictive analysis, analytics, and data mining, reporting. And next, random forest classifier. Random forest classifier is a popular machine learning algorithm that is used to both classification and regression tasks. And it is an assembled learning method, which means it combines the predictions from multiple machine learning models to make more accurate predictions. And the random forests are mostly based on by decision trees and decision tree algorithms, and they also offer advantages over individual decision trees. And also, random forest classifier is a versatile and powerful machine learning algorithm that is particularly well suited for classification tasks. And also, random forest is an assembled learning method that combines multiple decision trees to improve classification or regression performance. And it is a tree-based model where multiple decisions are trained and on random subsets of the data. And random forest provides robustness against overfitting and is also known for high accuracy and ability to handle complex data. And gradient boosting classifier. Gradient boosting classifier. Gradient boosting classifier is another assemble learning method. It builds trees sequentially, and it starts with a simple model and then fits additional models to the errors of the previous model. And gradient boosting often results in strong predictive performance and is used in both classification and regression problems. Now coming to the coding part, here we have imported different libraries for logistic regression, random forest classifiers, and SVC for sklearn bot and train for training and testing and splitting of data and load iris. And next, we are setting a random set of 42, and random set is set to ensure that the results of the machine learning models remain consistent across different runs. It's used as a seed for random number generation. And next, we are defining a classifiers. Here, in this section of code, uh, a list of classifiers is defined. Each classifier is a tuple consisting of name and an instance of a machine learning model from sklearn. And next, we are training and evaluating models. For each classifier, it trains the model using the train data xtrain and ytrain and with model.fit. And also, it evaluates the model's accuracy using the test data xtest and ytest and calculates the accuracy score with the model.score. And finally, it prints the name of the classifier and its accuracy. Here we can see the output. Logistic regression accuracy is 0.710 and random forest accuracy is 0.768 and gradient boosting accuracy is 0.698. From here, we will start visualizing the data. Here, for visualization of data, we use different graphs such as bar graph, pie charts, histograms, line charts, line graphs, and etc. Here, I used bar graph for visualizing the match venue distribution. Here are the different stadiums where the matches have been takes place. The x-axis contains the names of the stadiums, and the y-axis contains number of matches. Here, Dubai International Cricket Stadium have has in all stadiums in Dubai International Stadium played more matches. More than 750 matches are played in Dubai International Cricket Stadium. And after that, Super Sport Park has second place. There, 500 matches has been takes place. Now I will explain the code how I generated the bar graph for this data. Here, I imported pandas as PD and matplotlib.pyplot as PLT. And I given data, and this is the CSV file I given here. And after that, this is the figure size, which contains width and the length of the graph. And for X, I labeled as venue, and for Y, I labeled as number of matches. And I given the plot.title, I given a title as match venue distribution. And now I'll explain the coding part. Here I imported different. Here I imported two libraries, pandas and lib.pyplot, and which is commonly used for data manipulation and analysis. And next, here a data frame named data is created by reading a CSV file, and you should. And next, this line venue counts is equal to data of venue dot value counts. This line creates a new series named venue counts, and it counts the occurrence of each unique value in the venue column. And next, it will this line sets the figure size for the this line sets the figure size for the upcoming plot to 10 inches in width and 6 inches in height, and it determines the size of the outplot. And next, plt dot plot dot bar venue counts index, comma venue counts that value. This line creates a bar. This line will creates the bar chart using the matplot library, and it plots the venue names index of venue counts on the x-axis and the number of matches played at each venue on the y-axis. This bar chart visually represents the distribution of matches played at different venues. Next, plt dot x label. I named it as venues. For y, I labeled as number of matches. And here I given a title as match venue distribution. And this line rotates the x-axis tick labels by 90 degrees to make them more readable when the venue names are long or overlap. And plt dot tight layout, this line ensures the plot layout is adjusted properly and preventing any labels or elements from being cut off. And plt dot show, it will execute the whole and it will display the bar chart graph. And this is the output of this graph. And this is the graph for bowler's performance, means total wickets. The highest wickets are 500. And now I will explain how I have created this bar graph. Again, here also I imported libraries, and here this part of code, this line performs a series of operations like data.group bowler. It will group the data in the data frame by the bowler column and create a group of data for each unique bowler. And innings wickets, these are the total wickets taken in that innings. And reset index, it will reset the index of the resulting data frame, creating a new index from 0 to n minus 1. And plot dot bar of comma bowler wickets, these are used, this part of code is used to create a bar graph. And I label plt dot x label, x axis I labeled as bowler, and y axis I labeled as total wickets taken. Here you can see. And this is the graph. And next, this is a line plot for runs from ball, which means we have in the whole data set we have zeros as between the 8,000 to 10,000, and here singles we have ones we have 10,000, nearly 10,000, and twos we have more than 2,000, and here three runs we have between 0 to 2000, and we have nearly 3000 fours, and 5 runs for balls. For a ball we have 5 runs as between, it is equal to between 0 to 1000, which are very less. And this line plot graph will show the runs from each ball. Next, and this is a bar graph for the top 10 bowler performance. See here in this bar graph we see the highest number of wickets taken. These are the top 10 bowlers who had taken highest number of total wickets. Here Saudi is the leading bowler who had taken nearly 500 wickets. And next Sodi, next Azmal, next Sahid Afridi, Santner, Amir. Now, again, here we have used the same plot dot bar for the creation of bar graph, and x-axis we labeled as bowler and y-axis we labeled as total wickets taken, as same as to the before code. And next, this is a scatter plot graph. Now I will explain about what is a scatter plot graph. Scatter plot graph is also known as a scatter plot diagram, scatter diagram. is a data visualization type used for the statistics and data analysis, and it is a graphical representation of individual data points in a two-dimensional space with one variable plotted not on the x-axis and another noted at the y-axis. Here, the main reason for using the scatter plot is for it will for the individual data points are two variables and identification of patterns and correlation assessments. And it is also used for data clustering. They can help identify clusters or groups of data points is that exhibit similar patterns. Scatter plots are a fundamental tool in data analysis and statistics for visualizing and understanding relationships between them. Now, I will explain the code part of the scatter plot. Where we imported pandas and we exported the CSV file, and the X column is the innings runs. The X column we have innings runs, and the Y column we have innings wickets. Innings wickets that were the two only here we are labeled for X axis labeled as X column means which means innings runs, and Y column we been innings wicket that we are labeled here. Next, for creation of a scatter plot graph, we use it that plt dot scatter transits data of data. Here, this line creates a scatter plot. This line creates a scatter plot using two sets of data, x column and y column. And this in this case is the innings runs and the innings wickets. And here alpha is equal to 0.5. It means this parameter controls the transparency of the data points. An alpha value of 0.5 make the points semi-transparent, which means we can be useful when multiple points overlap. And next, this line will add the labels, and this is the title. See, here we can see the title, scatter plot, innings runs versus inning wickets, which we have given in the part of the code. And here plt dot grid true. And this grid is the, here we can see the grid in that visualization of data. Here, this is the grid we have, for this we kept here. And we are plt dot show. To execute the graph, we use plt dot show. And this is the overall graph. Finally, this line will displays the scatter plot, and the plot will appear on screen. And the plot will usually represent and helps to understand here. It will help us to understand the innings runs and the innings wicket at which how the innings runs are going on and which point of the innings we are losing the most wickets. Next, I visualized innings runs and or wickets taken over time, monthly aggregations. Like I showed in before the data set, in the data set we have also dates in which the match has takes place or in which the match has done. So here I visualize the data by using the dates. Means see here you can see by in the months or in which month we are getting more wickets like that. For that I created a graph. Now I will explain the Now I will explain the code for creation of this graph. Here we imported pandas library, and next we are given selected columns such as date, innings runs, and the innings wickets. This line will filters out the next inning data is equal to data of innings is equal to 1. This line will filter out the data to include only rows where the innings column has a value of 1. This typically represents the first innings in a cricket match. The filter data is stored in the inning data frame. Next, here the date column in inning data is converted into a date time format using the pd dot pd.to date time function. This step ensures that the data column is treated as a date or a time variable for accurate time-based analysis. Next, this line aggregates the data in inning data on a monthly basis. It calculates the average of each column in each month. Then the result is stored in the monthly data frame. Next, this line sets the figure size for the upcoming plot, and it specifies the figure should have a width of 10 inches and the height of width of 10 inches and a height of 6 inches. Next, this line Next, this line creates a line chart using the matplotlib.plt, and it plots the innings runs data on the x-axis and the innings runs data on the y-axis, and use the determine values from monthly data dot index on the x-axis, and the label parameter provides a label for the line. And here, the marker equals to O specifies a circular marker from the data points. Next, here we are labeling the x-axis as date and y label has count. And this is the code for title. And this line rotates the x-axis ticks labels by 45 degrees, making them more readable. Next, this line adds a legend to the chart and distinguishes between the innings runs and the innings wicket. Here we can see, here this is the legend. And we have given a grid to the whole chart and plt.show to execute, and it will show the graph for us. And this is the graph, and these blue lines are the innings runs, and these are the innings wickets. Then this graph is a average graph of the on the monthly basis. And next, this is a correlation matrix heat map. Now, I would like to explain about the correlation matrix heat map. A correlation matrix heat map is a simply is a data visualization technique used to represent the correlation coefficients between the multiple variables in a data set. And it is a graphical way to understand how strongly two or more variables are related to each other. Here's here we need to know about the correlation coefficients. What are the correlation coefficient? Correlation measures the strength and direction of the linear relationship between any two variables, and correlation coefficients typically range from -1 to 0. See here, we can see here it is a range from -1 to 1, where 1 indicates the perfect positive linear relationship, and -1 indicates a perfect negative linear relationship. Either and 0 indicates no linear relationship. And correlation matrix, each cell of the matrix displays the correlation coefficient between a pair of variables. The main diagonal usually contains ones. Here we can see the main diagonal usually contains ones because a variable is perfectly correlated with itself. And in this heat map visualization, the correlation matrix heat map, it will visualize the coefficients as a color coded grid. Higher positive correlations are typically represented by blue, and while higher negative correlations are represented by shades of red, and zero correlations can be displayed as neutral in by. I created a correlation matrix heat map for the all columns in my dataset: innings runs, innings wickets, target score, balls remaining, total batter runs, and every column have a relations with any and with the other column. We can see in this graph. Now I will explain this code. For creation of the correlation matrix map, we use sns.heatmap of correlation matrix, comma n naught is equal to true and cmap is equal to cool warm, comma fmt is equals to point dot tf. Here, the correlation matrix, the data containing here the correlation matrix contains the data containing correlation of coefficients, and not a and not is equal to true. This adds numerical annotations to each cell, displaying the correlation coefficients. And CMAP is equal to cool warm. It specifies the color map for the heat map using cool and warm colors to represent positive and negative correlationships. And FMT is equal to dot 2f. This formats the annotation values to display two decimal places, and we given line width is equal to 0.25. And coming to the output explanation, the output that visually represents the correlation between the all columns of the data. Here, the dark blue indicates a strong positive correlation, and dark red indicates a strong negative correlation. Where white or pale colors indicate a weak or no correlation. See here we can check the correlation between the play route runs to target score. 0.24 is the correlation between the play route runs to the target score. And next, I created a histogram for innings runs and the histogram for bowler runs considered. Here again, I imported the libraries pandas and matplotlib libraries, and here I given a column 1 equal to innings runs and column 2 is equal to bowlers runs considered. Next, I have given the figure size 12,6. These are the width and the height of the graph sizes. And plot.hist is used for the creation of the histograms graphs. And these lines are the x label as column 1 and y label as the frequency. And coming to the output explanation, and x-axis contains the innings runs and the y-axis contains its frequency. This is as same as before, like that. There are zeros, we have score of zeros, we have 0 to 10, we have more than 1200 innings runs, and we have a 250 innings. For an innings we have 250 runs, we have between 0 to 20 nearly, as same as with the bowl as same as with the bowlers. Next, I have created a box plot of innings by the countries which batted in the first innings. Here we can see West Indies played most time. West Indies have played the done the first innings as selected for batting, and it scored 250 runs. And next, England has scored more than 200, nearly 210. And these are the countries that have played bat first. And these are the box plot representation of graph, and these are the runs for the bat first teams. And here we use sns dot box plot for the creation of the box plot graph. Coming to here, this whole code creates a pie chart to visualize the distribution of extra runs in cricket matches. And these are the libraries we have imported. And next, this line groups the extra type column and the calculates the sum of the extra runs for each type. And it creates a panda series and extra runs distribution. Next, this line setups a figure for plotting with a size of 6 inches width and the 4 inches height. And next, here Here we created a pie chart using plot.py and labels as extra runs and distribution index and the label for each slice of the pie. And here start angle equal to 140 degrees rotates the pie chart to the start from the 140-degree angle, and the output and this whole code helps viewers quickly understand how extra runs are distributed among different categories in the dataset. And next, and this is also a pie chart for the teams outcome of the matches like chased successfully and not chased successfully. Here we can see 52.4% of the teams not chased successfully, and here only 47.6 has chased successfully. This means this graph gives us that the teams which batted first have won more than the teams which bat second. And next, this is a pair plot graph. Can have for the all the columns. It will create multiple plot graphs, and this is created with the SNS dot pair plot of data columns. And this is the project I have worked on. Now I want to conclude this. The data warehousing project successfully cleaned and analyzed the cricket match and data set, providing valuable insights through various visualizations. And these visualizations helps in understanding match venues, bowler performances, batsman's performances, and relationship between runs and the wickets, and the outcomes of the matches. And the project serves as a foundation for data driven decision making and further analysis in the domain of cricket data.